We're now moving into the realms of crushing rock, breaking rock, and recovering diamonds, and most of all, making sure you don't break them. So thanks to Derek Lahee for having his team present to us this afternoon. We're going to have two presentations, initially by Derek and then two of his colleagues. Derek completed a national higher diploma in extraction metallurgy at the Technikon Witwatersrand School of Mines. He is a member of the South African Institute of Mining and Metallurgy and is the managing director of Consulmet Pty Limited. And he's going to talk to us today about two very interesting kimberlite mine projects which the company is currently involved in. So over to you, Derek.
Okay, thanks, John. Yeah, look, I think we're quite lucky. I was just listening to these road header continuous mining tool subjects. So we're quite lucky today. The last 2 years, we've developed a hard rock kimberlite plant, a big one, 500 tons an hour, and then we've been been lucky to just after that do a very soft kimberlite. So I'm going to compare the two today, and some new bits of technology we're putting into the flow sheets, show you what we're doing, what's out there. And before I start, let me just go to my intro. I just thought, John, we're always talking to students as well. Amongst all the old dogs, we've also got a lot of students. So I thought I'd introduce one of my bugbears, which is good process engineering basics. All these big projects, I see a lot of things going wrong, as we all do. We're talking about mining, but also in process. And I wanted to go through some good process engineering fundamentals, like absolutely basic, which might seem very basic to a lot of us. But yeah, if we are talking to the students, I just want to get that out the way. Then I will go to the hard rock kimberlite project that we've done in Zimbabwe. And then I'll talk about the highly weathered tefacious type of kimberlite that we've been doing in Angola, that we're busy with right now as we speak. Both these projects are very recent. The first one's being commissioned as we speak. The second one's currently in construction, only with the bulk earthworks. So good recent history here, and nice for everybody to have a look at it. So I'll just move on to my little bugbear with some fundamentals. So flow sheets and P&IDs. I mean, all projects start with a flow sheet and then a P&ID. But I see a lot of guys just doing really simple line diagrams for flow sheets and really not putting any effort into the flow sheets and the P&IDs. And actually, that's your vision of your plant. If you're a good senior process engineer or process manager, that relates to the layout, ultimately to your layout, your mechanical layout. And the more care and attention done to the flow sheets and the P&IDs, the better your plant deliverable is going to be. And we seem to be losing a lot of the darker arts of process engineering, well, all the basics, actually. It's not even dark arts, the basics. So, yeah. So I just wanted to highlight the importance of professional flow sheets. I mean, it's the senior process engineer. It's his vision. It's his vision through the flow sheets and P&IDs, and that translates to a good general arrangement. So what do we get out of it? Well, we get quality mechanical equipment lists. We get all your installed kilowatts critical to your OPEX. We get great mass balances. I see terrible mass balances out there everywhere I go, and it's basic stuff. Your solids balance and your water balances. And guys just get it wrong, and then they can't understand later on when all the equipment size is wrong and they're getting there's no safeties, etc. And detailed P&ID information. Also a lot of basics which are forgotten. On these bigger projects, you can probably get it away with on small scale things, doing things pretty basic. Mid-tier, you can do the basics correctly, but on your large projects, you need to take a lot of care and attention and take time in your initial design phase, which will save you a lot of pain. So just for the students out there, I just put, this is a DMS flow sheet. I wanted to put just a couple of the red bubbles are the basics on the flow sheet. Battery limits. It's amazing how often, the guys get the battery limits wrong, either within the company, between their own modules, between the DMS and the recovery, or between other contractors and subcontractors on big projects. Those battery limits are critical. All the little lines with the arrows on the ins and outs of the plant. Detailed mass balances, percent solids volume by volume, percent solids by mass, your water balances, and your solids throughput through the plant, and doing a fines, a middlings, and a coarse balance on your flow sheet, so that you understand the parameters of your PSD. Now, you've designed for a PSD, and not absolutely critical. I haven't put it here, but starting with a good PSD and having the window, a nominal PSD between your max and your max coarse and your max fines, having a nominal PSD, particle size distribution, absolutely essential. It's amazing how many projects go wrong when the PSD is wrong, and putting it on your mass balance so that everyone can see where it came from and understand it. And on the right hand side, the right hand bubble, we obviously have the so detailed mechanical equipment lists and kilowatts. And I see the more detail you put on the flow sheet, on the mechanical equipment list on the right hand column, the equipment sizing, the installed kilowatts, it was a vibrating screen, put 6-pole motors, 8-pole motors, model numbers, just a lot of detail. It shows you put care and attention into it. And then the right hand side, obviously your kilowatts are critical. So just a little basic lesson. Get the guys out there are just doing simple line diagrams, and there's so much you can put on a flow sheet. Here's the vision and of the plant and the creative side of the plant. And like I say, a good process engineer will translate that into a good general arrangement drawing, which benefits everyone in the long run. Next is on to P&IDs. All right, thank you. Okay, P&IDs, we can see here just a lot of detail in the average P&ID. The guys are doing so many things wrong on these P&IDs, which you can go into so much detail. Just have a look at the spray bars, your distance between your spray nozzles, your valves, your width of your spray nozzles across the screen, the valve details, lining details, pipe details, minimum slope on your pipes, P&ID control routes, and sump valley angles. A lot of guys take the P&IDs for granted, but good longevity on the project, on a big project, and a lot of detail into the P&IDs, absolutely essential. Good design fundamentals. That's what we do. Okay, so the first project I'm going to move on to is a 500 ton an hour hard rock kimberlite process plant, 90 MPa plus. It's in southern Zimbabwe. It's been around since 1998. I was quite lucky. I did the original sampling plant when I was still with Bateman's. I built the first sampling plant. It's been a very successful project. They're moving on to a bit of lower grade material now. There's 3 pipes. And as I say, the kimberlite's sitting at about 90 MPa. And so milling was out, autogenous milling was out. And we had to do conventional crushing. We've got 4 stages of crushing here, actually. I'll show you all the layouts just now. For us, it's quite a big project. Design, fabricate, transport, and install 325 superlinks. As I say, we're busy commissioning right now. 5,500 cubes of civils, 8 megawatts installed power, and just taking note, big circulating loads. We had massive circulating loads. A lot of granite dilution, which doesn't help and increases those circulating loads. I think in the future, waste sorting is going to be so. Where we're going with waste sorting, with the near infrared and all the optics and all of those good things, I think it's going to make a huge difference in these type of deposits. We're in our infancy there, but it's going to make a difference. So, yeah, as we can see, southern Zimbabwe, right next to Moroa, or at Moroa. Right, off we go. Big plant, as you can see, big footprint, almost old style footprint. We've got a huge dump of low grade tailings, and bottom right hand corner we've got the two front ends. So the left hand one is tailings only, the right hand one is run of mine from the pits. The 2 pits are very competent. Some of the low grade material is very competent. And then their pipe 3 is highly weathered. So we had this dichotomy of ore to deal with, and I'll show you on the scrubbing what we had to do when we treat pipe 3. Yeah, so we've got double scrubbing. We've got a primary scrubber. Then we've used these rotary log washers as a secondary scrubbing unit for the highly weathered material. We've got Kawasaki IMS secondary crushing. We've got VSI TechRock VSI for tertiary, what we call quaternary here, because we've got a pre-primary because we had a very big lump size. So we put a pre-primary jaw and a primary. So we got clever with the labeling. But yeah, so we ended up with quaternary crushing. You'll see a lot of stockpiles, and I'll come to it later. And I think it's something, if you've got long duration, if you've got a 20-year life of mine, or even a 10-year life of mine, 20, 30, 40-year life of mine, you know, we go to these big plants, and some of it's weather conditions like Canada and Russia, and you can't put stockpiles due to the igloos and the limited space. But if we are out here in Africa and you've got the space and you've got 30-year life of mine, I don't know why people don't put stockpiles. You know, try save money on the civils and not put stockpiles. I understand people will come with security and all sorts of things, but really from a plant availability and utilization point of view, makes a huge difference. I mean, in this plant here, you can isolate all your areas and run your XRT modules in the middle here, and run your DMS, and you can run your individual secondary and tertiary crushing circuits alone if you have any maintenance on the rest of the plant. So yeah, I'd say a forgotten art in some of the designs. Guys are going for really compact plants, which I understand in a lot of circumstances. But if you have a long life of mine and you want to push up your availability and utilization, let's not forget the good old stockpile. Yeah, the summary of this plant, it's jaw crushers up front, and then we've got a primary rotary barrel, just a big scrubber. We've got log washers as secondary scrubbers. Secondary crushing is the IMS Kawasaki crushers, which are the groove liners. I'll come to them just now. The groove liners, which have been quite good for diamond breakage with the interparticle crushing. Tertiary crushing, to save costs and power, instead of HPGR and that, we're using the VSIs with the rotors, with great success on many low-cost kimberlite operations. All the +10 here, all the +10 is off to 3 XRTs, and then we've got a very coarse distribution. So even with the XRTs or bulk X-ray, you end up with 3. We've still got 3 by 200 ton an hour DMSs because of the big circulating loads. And then for the DMS conchs, we've got a final X-ray sort house. We were using the new DebTech Mark IIs. I'll come to those now. They look like really great machines. Yeah, and it's interesting. Both the designs I'm going to show you now, both of them are using XRT on either +6 on the second project, and in this case +10 or +8. So both designs, XRTs or bulk X-ray, has just become standard on as a coarse concentrator. Anything +6, +8, +10. I find them really great on kimberlite because you get a very low yield and direct to hand sorting in most cases, depending on the mineralogy. But in the cases I've dealt with in both these projects, very, very low yields, and you can go direct to hand sorting. So yeah, whereas again, 12 years ago when we started putting XRTs in as primary concentrators, and it's now become a standard piece of kit now. And the DMSs for fines, we still can't get the capacities and the recoveries. We're still using them for fines recoveries. And again, over a 50-year life of mine, the good old DMS is still doing its job in the circuit. We've got a big thickener. Well, not so big. The second project is quite big. This is a coarse kimberlite, so we don't really have a slimes problem. We have smegtite, which causes a bit of dispersion and some settling problems, but it's not a massive challenge. Our challenge here was the crushing efficiencies and crushing efficiencies and circulating loads. Yeah, so quite interesting. We've got 2 modules like you see on this slide here. One is for tailings only, and one is for fresh feed. This is the fresh feed one, and you can see we're using Osborne crushers. Osborne, what we call a pre-primary, because we've got a big lump size and we just nip it down. We've got our Osborne prime, what we call the primary. It's a secondary crusher, just to again to get it down to size to prepare it for the IMS Kawasaki's. Used Osborne here, no complaints, been fantastic. Funny enough, just talking about cost and money, on another project recently up in Lesotho, with the client, we made a decision to buy a Chinese crusher, a jaw crusher, which was still quite expensive, but about a fifth of the price of say an equivalent Osborne or Metso or any of the Sandviks. And they're just interesting. The crusher crushes beautifully, no problem. So the quality wasn't bad, but the forces we got, you know, were crazy. Eh? So all the forces were out of balance, and the civil design and the civil rectification work we had to do on it. Actually, we should have just bought a crusher for 5 times the price, because it just ripped itself out of the civils and that. And I must admit, the new jaw crushers on the market today from all the big suppliers, really all the forces are balanced within the machine and make a big difference on your civils, even though you can see there's still significant civils here. Yeah, so we tip, we've got an apron feeder, we got a VGF, pre-primary and a primary. That's just the front end, nothing special. The nice thing is that the right on the back, this corner here, where we're feeding the tailings, we can also feed fresh feed. So you've got redundancy in the feed. I always believe in bottlenecking the plant downstream and really overfeeding if we can, you know, the front end. So really bottleneck downstream. And we've got quite a bit of over design in the 2 front ends to just ensure that we bottleneck the DMSs and the XRTs. So primary and secondary scrubbing. You know, primary scrubbing, we just went to a big washing barrel. Secondary, we've been trying these units out from Ireland. This is the 4th project we're putting them in. We put 2 big ones in here, the CDE 250s, and we're very happy with them. I think over the long term, it's going to be interesting. We've put them on smaller kimberlites and on alluvials with great success. Really clean, sticky material up nicely as a secondary wash. I wouldn't put it as a primary, because it can't handle the lump size and the aggression of a high lump size. But as a secondary, to really clean it up as preparation, and especially in consideration of bulk X-rays. You know, your feed preparation and any X-ray, whether you're putting a Bureveshnik or a Tomra XRT or whatever on a bulk XRT or X-ray, your feed prep is becoming more and more critical. And yeah, we've installed 2 of these now. One of the unintended benefits, which I've discussed for John before on the alluvials, is the elutriation. And we get an elutriation with all the organics, blasting caps and vegetation, any vegetation in the dump material. We actually can float off the back here and elutriate and then dump it in a bag on the back. But it doesn't then, if you're using XRT, which ejects the carbon, you don't have that as big a problem. You still get a problem because, interesting, a lot of the wood is fossilized, so it's still heavy. So you don't get rid of all your wood chips and everything. But some stuff does go through, and but you clean up 60–70% of it. So yeah, not great clay, because mechanical attritioning, so it gets rid of clay, and a benefit out of this, of course, XRT has been elutriation, which has been a bonus. In all of these things. Again, these are 2 big projects. This particular project with coarse kimberlite with a lot of silica and granite. I'm going to be very interested to see long-term the tungsten paddles, these tungsten tip paddles, how they're going to last. You know, I love this arrangement. This non-helical spiral arrangement is brilliant, pushes all the material beautifully and smoothly out. We've tried other units with the old paddle log washers, and we've tried different arrangements, and they haven't worked so well. So this non-helical spiral arrangement is fantastic. And as I say, the big test now is going to be how many hours on large tonnages are these tungsten tips going to last. So far, for the last couple of years, we're doing quite well on smaller mines, into the really well in some of the data we're getting back. But yeah, that's going to be a test, and we're going to check it out. Okay, let me just move on. All right, next to this, you can just see our secondary modules here. There's the log washers, log washer product. We go to classification, and then plus 25 all comes back into these secondary crushers, which I think they IMS 1300, Kawasaki 1300, so they're big units. We again probably on our 4th project with them, and very happy with them. I mean, some guys have had problems with them. I'm speaking to some guys from DRA on one of the big projects, had some massive problems on the IMS units, but so far we've been quite fortunate. I think it's also probably the way you install it, maintenance, regular maintenance, the way you operate it, but you've got to look after them. It's got the groove liners, as I mentioned. John did mention diamond breakage earlier. I don't think I'm going to get too much time to go into it. But we with the interparticle crushing, we have seen a slight benefit with the groove liners in these units. I mean, they're using them up at Letseng. They put them in at Likabong. I saw them at Likabong, and I've seen them. Yeah, so they are benefits, and we're quite happy with these units. Okay, I'll just move on here. So we always got that old dilemma on recrush, getting a cheaper capital units, not wanting to spend money on a high pressure grinding roll. The hardness of the material, if you've got really hard kimberlites with a HPGR and the maintenance on it. And yeah, over the years we started with the VSIs, and we sort of followed the chief engineer. I think I was talking to John yesterday. It's funny how you follow people, but right back to the old Barmac days, with the Sodala, Barmac Sodala license. And then the chief engineer moved on. I don't know where he went. And then he moved on to Osborne, and we put Osborne units in. And now he's moved on to a company called TechRock. And we're really getting the drop boxes right, or the flood boxes and the dead boxes right, and getting the pedals, because they're high maintenance on the pedals, but getting those pedals right. Diamond breakage, yeah, I would say not obviously not as good as an HPGR, but probably fit for purpose. Remember, we're already down, we into the finer diamonds here for fine diamond liberation, and so I suppose that exercise has still got to be run. But as a capital and on an efficiency point of view, on our percentage passing -6, we're getting wonderful results, and it's going through. But I'm sure there'll be a lot of arguments on diamond breakage, but I'll just be careful. This kimberlite's incredibly aggressive, and an HPGR will take a lot of pain as well. So yeah, that's our tertiary crushing units. You can see a big layout at Zimbabwe, quite lekker. You've got the big granite copies in the background. Really nice site, Rundi River, 10 kilometers away. And as I mentioned earlier, we're busy commissioning, so that's quite nice. Competent material, we couldn't get away. Unfortunately, we 8 or 10 millimeter cut on the core side, so we went for our good old DMSs. Each DMS 4 times Multitech 420 millimeter cyclones, each 2 Multitech cyclones fed by a Y-shaped distributor. When we put one of those Y-shaped distributors in 17 years ago, I think they're absolutely awesome in getting equal pressure and equal flow to your twin cyclone installations. And we're very happy with the DMSs. We've commissioned them, they're running well. And you can just see, if you go, all the concentrate, our security is not in place yet, but all of this is going to be red area. This was taken in February. This picture was taken back in February. You can see this will all be banked off, and we are jet pumping each of the fractions up to the central recovery plant with the X-rays. In the background, you can see the XRT feed conveyors. So there's a bank of 3 XRTs for the plus 10 millimeter, plus 8. Whatever it is. There again, you can see the DMSs. Just one of my old bugbears. I think a lot of people know I've been around a long time in the DMS business, but the guys are just not, the DMSs are getting more compact. Guys are building them compact, but they're not taking into account their cyclone selections are inadequate. medium to ore ratios. I've seen some DMSs in the market at 3.5, 3:1 medium to ore ratio. And everyone's saying, well, I've got where we put a 55 kilowatt or 75 kilowatt on a cyclone feed pump. There, guys are boasting that they've got a 30 kilowatt, you know, and so they're saving money. But their medium to ore ratio is 3.5 or 3:1. I don't know what that's doing to their diamond recoveries, but it can't be good, especially on fines. Plate work designs are terrible at the moment. Header boxes and sumps, you know, minimum plate work angles, pipe work angles because of heavy medium. And then maintenance, maintainability and operability. Again, on a bigger mine, you've got to take a slightly different mindset. And life of mine, maintenance and accessibility. I was going compact for everything, and then the fitter and the boilermaker can never work on a pump or get it out and work on it or get to it. And yeah, so you've got to think about maintainability and operability. It's a big factor. Basic designs, I know, I understand with the juniors, the mid-tier, not so much, but the juniors, I understand when the plant has to be compact and a rotary plan's got to be put in as is. That we understand that. You've got a world-class deposit, and you must treat it with the respect it deserves, and make it easier for the guys running the plant. Okay, I just put we had a massive degrit because of that granitic kimberlite and all the contaminants. We've got a huge degrit circuit here. The photo doesn't do it justice, but it's about 15 meters in the air. Massive degrit. A lot of projects undersizing their degrit. You're trying to reduce as much grits to your thickener. I just wanted to, a great thing that's happened in our business the last 7 or 8 years is preconditioners. You know, instead of coagulants, much cheaper preconditioners, and charging the water or changing the charge on the water, and just preconditioning the water to save you on flocculant and help you with clear overflow, clear water. We use this VAT slurry tech. They do a lot of our test work, this Clary V44, and it just charges up. All the overflow goes to the slimes dam and then comes back as return water. So it's not a continuous dosage. You maintain the level on conductivity. You have a conductivity meter and you have a pH meter. And you see the levels drop, you just add a bit more. I add it out at the dam or add it into the plant anywhere here. And what we, in previous applications where we haven't been able to get kimberlite slimes settling at all, this has been a massive game changer where the slimes is actually settling. We're getting clear water. Not so much more compaction and underflow density, but we are getting your shear forces for your pumping. Your viscosity is lessening a bit, and we able to. I mean, Yashin after me will talk about those big pumps at the CTP, and in the old days, it was just impossible to pump a high viscosity and the maintenance. So he'll chat about that. But yeah, we're able to reduce the kilowatts on the pumps, and makes a big difference. So. Makes a lot of kimberlite slimes that we've looked at in the past were just impossible to treat. It's a bit of a game changer. Yeah, I brought this up earlier, but I'll bring it up again. Stockpiles. I've used stockpiles and this and on the next project as much as possible. You know, the more compact our plants are going, you've got a problem with a XRT or a small problem in the DMS, and you end up shutting your whole plant down and have these arguments all the time in operations. But you've got to think about your overall availability and utilization. So the more surge you have is good. You know, it can help you fix a 8-hour problem in front of this or whatever you have to do. We're building all our tunnels above ground, so we're not going underground. Got a really neat design now. The little blue rectangles there, you can see where the feeders are going in. And a lot of duality on the feeders. We only need 2, but we've put in 4 per tunnel. This is the DMS stockpile feed tunnels. Okay. Yeah, so I'm going to just race straight to the final recovery. We're trying the new DebTech machines, the new Mark IIs. They were expensive. Yeah, very expensive compared to the flow sorts, compared to the Bureveshniks. We chose 5 of them for this project. And yeah, the proof will be in the eating shortly. There's material going through them now, and we'll have all the data. But very impressed with them to date. I mean, the number of settings we can set them. There's about 20 or 30 variables you can play with, so you can really fine tune. I'm not an expert on it, but I'll get to know it over the next couple of months as we commission. But you can sort of fine tune your machine to your product and really set it up nicely. It's a wet machine, and we're quite happy with them. The compact layout of the machines has been good. Slightly higher capacity on fines than, say, the flow sort, and we spent more on capex. But it's interesting how the final recovery building compacted a bit. So more on capex on the machines, but the height of our final recovery building came down a bit from, I think we would have had to select 12 double pass flow sorts here, equivalent, which was still cheaper than these machines. But our building was another 8 meters higher. So the recovery became quite compact using these. And I haven't got data yet, but hopefully they made out to be. So far they're looking quite nice. As compared to the old Mark 1s, I just gave advantages. I think the big thing, the Spellman X-ray system, you can see they put a Spellman X-ray system. Control cabinet as compared to the old one built into the machine. I like this advanced diagnostic capability. As I say, I'm still getting to terms with that, so nobody asked me anything too complicated. I think it's maybe not the right machine for out in the bush somewhere for a small show, but when you've got, again, a long life of mine and you've got the technicians on hand and you've got the capital and you want to do it properly, and then you can make use of that advanced diagnostic capability. They've now upgraded the remote support, like all the guys are doing. I see the Tom Wright guys are doing it and BV guys are doing it, which is a bonus. The ASI system, I think, is fantastic. The old ones used the magnetic and proxy switches, which were horrible. And the new ASI systems are all built in with the PLCs. That's actually really nice. New feeder designs. Oh, okay. Sorry, I'll just flick to the last slide. And you can have a look at the overall layout of the plant, which is a big plant for Zimbabwe. And it shows guys are still investing in. We were talking about the rarity of diamonds and how difficult it is to find deposits. Our clients took a big risk here and a big investment on a fantastic mine so far that's been running for two decades and still producing. But you can see the dual front ends, rotary barrels. There's the secondary log washers, secondary cone crushers. All of these concrete blocks here are all the stockpiles, plus 10 off to the 3 XRTs, the 3 conveyor belts, and your minus 10 is off to the 3 DMSs, our final recovery in this area here. And this was, again, February. We've now put gravel on all the earthworks and tidied it up a bit, but it looks nice. So that's a basic footprint of a sort of a modern hard rock kimberlite plant. I think the concept of the bulk X-ray XRT just becoming a set in stone on our flow sheets here, whatever you choose, whether you choose Bureveshniks or Tonras or any of the other brands out there. But that's been a major game changer. We ran an operation in Lesotho for 4 years now with 2 XRTs. I'll give you some good data. The gentleman before me was giving us some nice operating cost data. But we're sort of sitting at about 3 Rand 50 per ton, 3 Rand 50 a ton with power per machine, which is fantastic. You know, so we ran 2 machines up there for a couple of years, sitting with power at 7 Rand 50 a ton for the 2 machines. That's really, really good data. I mean, there is a caveat to that, though. We had a very high level technician on the ground. So you're talking a highly paid guy looking after the machines, like, you know, whether it's bulk X-ray, it still must be like your final recovery. You've got to look after the machines. A lot of these machines are shoved out into the mud and and into the environment, and they're a complex machine, and you can't do that. So you've got to look after the machines. If you look after them and you get predictive maintenance on the J chutes, when to replace them after X many hours, and you just look after it, you have good voltage control, you don't have big power surges, and you're not going through those sensor bars and all those funny things. And a high quality technical team, or one high quality guy or two high quality guys, then you can sit at those numbers. I've seen the numbers scream when you don't look after the machines, and the machines start packing up. So yeah, sitting, as I say, £3.50 a ton, and maybe somebody can write that down. That's good info. All right, so that's my hard rock plant, big layout, recent, being commissioned as we speak. And I'll now move on to our next plant, which is, this was Zimbabwe. And just as this was ending, we were awarded a contract for up in Angola, 30 kilometers from Katoka. I saw the Katoka pit just now. So this is going to be Luashi. Some people pronounce it Luash, L-U-A-X-E, some Luashi. This is a big plant, 1,500 tons an hour run-of-mine feed. It's weathered kimberlite, completely different. So we're sitting at 30 to 70 MPa. And it just, the mill obviously chose itself, autogenous mill. We're quite lucky. We've been involved in a few autogenous mill designs. So we grabbed this opportunity. It was really nice for us. 30 to 70 MPa. I just put some salient points here. We're the first guys, I think, on a kimberlite. Somebody can correct me, with the eccentric roll crusher. Some of the problems being had at Katoka at the moment is hard rock getting into the MMD mineral sizes. And as the pit, obviously they're getting to deeper now, and there's more competent material, but the igneous or the waste rock, there's a lot of waste rock as well, and then it really stuffs up the conventional roll crushers that were so good on soft clayey material. So we've got a dual feed here as well. So if the really soft tufaceous material direct feed straight to the mill, well, we're quite lucky there. We've probably got 100, 150 meters still of that left to go. And then when we get this contamination, either very hard kimberlite or this which is rare, but it's mainly contamination from the waste rock, which some of the material sitting at 200 MPa plus, we can feed it into this eccentric roll, which a supplier, I'll come to it now, I can say that it can handle up to 400 MPa. I don't know, I haven't come across a 400 MPa rock, or maybe I have, but that sounds pretty hard. So yeah, so we've got we can handle the hard feed and a soft feed. I'll come to the risk with that just now. So we designed a 1,500 ton an hour. Just check my time. Yeah, hurry up. Designed a 1,500 ton an hour, the ERC, eccentric roll crusher section. And then downstream, there's phase one, there's 3 milling streams. So very similar to Katoka, there'll be 3 mills. We've just done phase one at 500 tons an hour. We've got a big front end doing 1,500 tons an hour to a stockpile, and phase one for now, autogenous mill. And obviously, again, here comes the XRTs are popping up again. We've got quite a complex canister system to handle the concentrate from the XRTs now, because it's a bit more complicated, because you're getting direct concentrate from the very, very low yields from the XRTs. Have got to be transferred across to the sorthouse and mixed with the glove box pickings. So yeah, you'll see a big thing here is once you've done the big front end with the mill, our footprint downstream reduces significantly, because in the initial phase of 70%, 80% of our material goes to slime. So in the previous hard rock plant, you saw big DMSs. Here you've got a much smaller DMS. You've still got 3 XRTs, but you've got a much smaller downstream footprint, which is great. This project, though, because of the big mill and the big front end, 8,000 cubes of civils up in Angola, and that's a challenge on its own. Yeah, 10 megawatts of installed power. So this is just phase one. So we'll end up probably at about 25 megawatts, 20 to 25 megawatts, I think, for the plant, for the 3 phases. John, you asked me to put a map in, but I just pulled this off the internet. So we are in Angola, northeast Angola, 30 kilometers from Katoka, 30-kilometer radius from Katoka. And the kimberlite, I believe, speaking to the client, very, very similar to Katoka, which has helped us with our design. Fortunately, it's always nice to have a reference point. Obviously, differences in the pit, but my colleague talking next, Rainer, will just go through a bit of the basics on the geology. Here we are on site probably 2 months ago. I think the right picture puts the scale of the project into perspective. I mean, on the right, top right is low-grade waste that they've stripped already from the pit. And you can see there's a 140H grader, there's a 980 Liber, and this is the plant site. So we're busy stripping and got 400,000 cubes of laterite required for compaction. Yeah, so it's good fun. You know, it's quite a challenge. We're having a lot of fun. Record rains, as we saw in SADC area this last season. This was just after heavy rains. You can see we haven't put the laterite down, then we redigging and recompacting. So good fun up in these areas. This is the layout, as you can see. The direct feed left out of picture is the 1,500 ton ERC module feeding onto the stockpile over here, and bypasses and direct tophaceous material is 500 tons an hour straight into the autogenous mill. Then after the mill, everything becomes simple. That's the real bonus of a mill. I know, again, don't ask diamond breakage guys. I think, I don't know, the old bankable feasibility showed Lahee at about $90 a carat. They've mined for 3-4 years. They've been putting it through another plant. So they've got good historical data on the plant. There hasn't been a lot of big stones, hasn't been a lot of high quality goods, but 90, I think with the diamond prices now, I might be seeing at 120, 130. I'm not sure, but the mill really works on this for liberation. And that diamond breakage versus liberation, I think will have to be weighed up. But I'm very impressed with it. It's a Tyson Krupp mill. I'll come to that just now. And as you can see, then we've got classification, primary classification, all the -6 in this case, not -10, off up to the top right. That's our DMS stockpile, feeding 100, much smaller DMS, gravity fed DMS. Client says the mine's going to be there 30, 40, 50 years. He doesn't want a cyclone feed pump, and he's right. He's right. You know, we tried to argue and complain. He said, Derek, once it's in, it's in. It's a gravity fed cyclone, and it's no moving parts on the impeller, and nice steady feed. And all the +6 is classified into 3 fractions: 6 to 12, no, 6 to 15, I think, 6 to 15, 15 to 30, and then we got a 30 to 70. So we've got the client's taking a bit of a punt on large diamond recovery, which is becoming quite common. So he's got a 30 to 70 fraction. He's gonna give it a whirl. The nice thing about all of these screens here, if that doesn't work long term, you can change your classification between. It's a nice thing about XRT and DMSs and having big classification. You can sort of play with all your different, you can go 4 millimeter to the DMS, 8 or 10, then change your fractions here and build a bit more capacity on this side. All of the coarse XRT tailings, there's classification again, up into surge bins, and then we've got IMS recrushers and pebble crushers. We've got an IMS tertiary crusher, and we've got a pebble crusher. So similar to the big IMS units you saw in the last one. And then refed, everything recirculated back to the mill. So ultimately, anything leaving this plant is -6, 100% -6. And we've got a big final recovery where we are using Bureveshnik machines. The client is familiar with them, and there's spares and there's redundancy in the area, and there's technicians. So yeah, we're a bit worried about those with the situation and the problems that side, but we hope they get delivered. We'll see. Here's our ERC. I just mentioned the dual feed. The hard waste will be fed through this. The hard waste mixed with kimberlite will be fed through this machine. 400 MPa rocks that the supplier claims can handle. Interesting enough, we don't have to, with an autogenous mill, we've got a 300 millimeter closed site setting. So we've got a 1.2 meter top size boulder going in, and a 300 millimeter closed side setting, which is great. So the other interesting thing about this is the autogenous mill doesn't need slabby material. So we selected this because of the uniformity of the product. You want a nice rectangular slab or block or cube or rounded particle going into the mill for the milling, for the AG milling. And this machine delivers a better product than, say, a jaw or a gyratory. A gyratory might be a problem. So we're hoping we get a better shape product, which is critical for autogenous milling. You know, autogenous milling can be a dark art. I mean, everyone will come with theories, but we run a few. Sure, it's got its challenges. So here's the eccentric roll crusher. I just wanted to show you guys. Like, there are a few of them in the world. One was in Indonesia, I believe, on a big tin or copper project. One was in Australia. One was somewhere in Europe, and one is going to Russia now. I'm not quite sure where. But funny enough, the 3 projects that I know of were shut down. I don't know why, war and care and maintenance. So currently there's none running in the world. So it is a project risk. We've tried to de-risk this as much as possible. One of the things worrying us is obviously a tufaceous mix with the hard rock. You can see where my little cursor is. There is a bit of a grizzly that scalps or fines ahead. And it's quite interesting. This crusher runs clockwise as you start it, and then as it gets lowered, it's counterclockwise. So it increases the time in the crushing chamber and the contact of the roll with the rocks. So it really increases the efficiency of the machine. But also the tines, then what it does is it cleans the tines of the fines, and all the fines run backwards here. So great unit, concave jaw, very interesting. So you've got a concave fixed jaw and this rotating roll, which has grooves. 146 ton unit. The unit we bought alone is 146. So our front end for this plant is massive. The mill is close to 200 tons. This unit is 146 tons. Challenge with logistics up to northeastern Angola. The mill we've divided into 4 pieces, and yeah, it's going to be interesting. Keep an eye on the space. Let's see. Okay, autogenous mill, there she is. We've put a big overhead crane. Tyson Krupp, we were lucky to buy this on auction. I think this was the old Petra mill that was going to Williamson. We refurbished it in our big, in the old Doorbell Engineering Works. Only guys that can work on a 7.5 meter diameter shell, unfortunately, in Africa. Can you believe that, with our fabrication facilities? So it was about to close. Some guys have bought it. I think it's called K9 or something, or K9 Fabrication Works, and I think they're related to the NCP milling guys. They've bought it, thank goodness, for our industry, and we were able to refurbish and re-roll and take all the flat spots out of the shell. And we've put a new girth gear on. We haven't gone for the complex Tyson Krupp. They've got I've forgotten the name, Corvex or something gearbox with a meshing between the. We've gone for a more conventional old style gearbox so that we can fix it in South Africa, and we don't have to get technicians from Germany and that, so we can fix it ourselves. So we put a new gearbox on. So we basically, when we bought the old mill, it was just a shell we wanted and a lead pump, and everything else we're doing a challenge on this as well. Rainer will come to that. Mill discharge crates, getting the right mill discharge crate and design, getting your product right onto classification. Yeah, there you can see the mill discharge end. That was February. You can see a man bottom right here, just shows the size of the mill. Quite a beast. 2.5 megawatts installed. Yeah, so it's a big beast. That's more than the Katoka mills, and it's more because of the problems they've had with harder rock at Katoka. So we've upgraded, and I think it's a good thing. Downstream, I mentioned earlier, just quickly, we've been through this, but you've got your 3 XRT stockpiles, your GravMax, not GravMax, your gravity-fed DMS, and your final recovery. And there's a big security and access area over here. Okay. I mentioned DMS only 120 tons an hour. The big thing with this project, the guys will come to it after me, but slimes handling is another beast because of this tufaceous and the smegtites and the talc and all the other clays. It's a different animal. So the mill's really great, simplifies your concentration step, but our slimes is a challenge, and Yashin and Rainer will bring that up now. Our XRTs, you'll see on this whole project, we've built everything. Even if I go back here, look at this. We've built all the, we're going to have 9 XRTs in the future, but we've built all the civils, even the DMSs. We built the civils for the next phase, for the next 500-ton phase and the next 500-ton phase. So we're taking that 8,000 cubes of civil, we're taking the hit now. So we're going to be going into phase 2 and 3. And you can see here's the XRTs. There's only 1 XRT getting installed now, but you've got space for another 2 either side, and another 2 and another 2. So 3 DMSs, and the recovery is expandable and modular. You can clip on all the extra X-ray machines. So the entire plant is like that, including the milling section. So we've bitten the bullet and we're doing the civils for everything. Here you can see the XRT building. It's a monster XRT building. There's a man, and the first 3 TOMRAs are going in. They're already on site. They've already been shipped to site. And yeah, you'll see much lower than the TOMRA system. We've done away with the used feeders ahead of it, and we're using the Vibramec prep screen directly ahead of the machine to feed the TOMRA, which saves tremendous height in the building. It's got very simple. That was a huge technical challenge, and we've worked on that hard. We learned it on Maroa what to do there. It's about motor sizes, isolators, and all sorts of funny things, because you want the exact distribution, same as the used feeder, onto the belt that's running at what, 2.4 meters per second or 2.2 meters a second. Got to get that distribution right. But as you can see, we don't have a vibrating feeder. Most of you guys will know it's screen, then feeder, then this, we've gone direct. And that is working for us. That's really nice. And then you can see we're doing all the steel, and the next ones can just slot in with all the phases. All the light gray there will just slot in. There's all your compressors and ancillaries. Okay, so there's the XRTs. Burevestniks, this was a picture taken 2 weeks ago, the new BV machines. We have got 10 of them, I think 8 or 10 of them, hopefully on the water in the next week. And we'll see how that turns out. Interesting, we learned from Katoka here, we didn't use the supplier designated machines we used still Burevestnik machines, but we used different model numbers that have been very successful at Katoka. So we learned a little bit from Katoka, which is good. So our final X-rays, all BVs, primary and secondary. All the XRT and X-ray concentrates. I just thought I'd put this in, the picture of myself there, John, looking happy.
About 5 minutes, Derek. You're going.
But yeah, nearly done. Yeah. All right. Okay. This is final slide. So just some basics again. We all design glove boxes. This is Fusitron in Cape Town. They've been around a long time. And I really see if you're sorting for 12 hours a day, your seating position, your lighting, your gloves, having space to move in your gloves, and access in the glove box to all the critical equipment. Really great glove box, expensive, of course. It's all done out of stainless. And then we've taken their standard canister system, because here they're taking glove box pickings from the bottom here and then up past my left shoulder into their final sort house with a really nice, simple canister system. And we've got another system which is not here with all the XRT concentrate that also gets shipped, because a much coarser product up to 70 millimeters. So we've custom designed our own canister system for our building for all the XRT conchs. So glove box conchs into our final sort and our XRT conchs, which you can't see here from the right, and straight into the final sorting area. This is another project, yeah, that we were involved with. This is not but it'll look similar to this. Yeah, that's a quick rundown. I know I'm running out of time. I could talk for hours. So, John, yeah, I'm done.
Fantastic, Derek. Wonderful to see that these projects are going on to the north of us. You know, we need a few more in South Africa, and very impressive, Derek, your attention to detail, which I guess is what you started with.
So Derek, the Bill McKechnie here, I'm just wondering, so the XRTs are for the +6 product, you said, is it? And the Burevestniks for the final material?
Yes, yeah. So correct. So we've the XRTs are for +6 on the last slide,
Yeah.
And then the Burevestnik X-rays are for the DMS concentrate, which is -6.
And are you in charge of the slimes management and all that sort of stuff as well? Now, I guess the tailings will be quite a challenge there.
Yes, we are. It's a massive challenge. I mean, this next slide, the guys are going to go through some of the. We're busy with the guys will just do the plant stuff, but we've just got all the slimes. Rano next up spent time on site gaining information for the slimes guys. Yeah, we're only starting the slimes dam design now. It's a hell of a challenge. Eh? It is. We've been looking at co-disposal, obviously. We're really battling to get the material to with this viscosity so we've got to pump it. So that phase 1, we've got to pump to a dam minus. Yeah, we've got to pump all the slime to a dam, and the 1 to 6 is just going out conventionally on a belt, which increases the OPEX significantly. But we have, out of this last test work, we have got some interesting information that we could possibly centrifuge on phase 2. We could use a centrifuge and get a 20% moisture, which can go into a belt, a 20% cake. But filter pressing and paste thickening with this tophaceous stuff, yeah, it's a challenge. Eh? So,
but hopefully with depth, things will improve.
Yes, we are hoping that's correct. We are. So we really are on worst case scenario. And funny enough, all the worst case scenario stuff that Yashin and the next, he predicted worst case and did his calcs, thank goodness, because the test work took so long. But it came out exactly as the worst case, unfortunately. But
thank you.
Right.
You know, Derek, there's a question in the chat box just about rehabilitation, and I guess, you know, it's something that's in everyone's minds today. I mean, we talked about it yesterday. I mean, there was it last year, a big spill at Katoka into the adjacent river, but so that's obviously focusing your minds. And you know, as these big projects get out there, rehabilitation and compliance become more and more important as well.
Yeah, absolutely. I mean, the way it was done in the past in Angola was shocking. So the mandate from our client was to just jack the whole Angolan standard up, which is what we've done. We've taken. I mean, we've taken 8 months now on this. We haven't even got to the final design, but because of the previous problems, we're really careful. We're between 2 major river systems. The one river is really beautiful, so we've gone out of our way to select the right area and deposit in the correct latest methods and world-class methods. The design's still coming out. There's still some work to do, but yeah, it is our whole focus has actually been we almost reverse engineered this from the slimes dam back to the plant. But we're under a lot of scrutiny, and it's been driven by the Angolan government, which is very good. They've been driving that in the environmental side, and nice to see.